Okay, so let's look at example number 13. This one is very similar to the problem we just worked. And instead of asking for the overturning moment, this one is asking for the factor of safety against the sliding. So feel free to pause the video for a couple of minutes and work on the problem, and we'll be back. So we'll be back. To approach this problem, you can either just use the equation from the reference manual, but the equation in reference manual again is a little bit confusing. So we can take a look at the reference manual first. So this is the equation I was talking about. That you have the retaining wall. You have the retaining wall. Oops. Right over here. So this is the equation I was talking about. A bunch of factors over here, but they did not really explain exactly what those factors are or what those parameters are. So this is definitely something you need to at least understand each of those and what those means, and to kind of go from there. So I can basically we can just write those equations first. I'm going to explain all those. So according to the reference manual, your Fs is sigma v times a tangent angle plus b times Ca plus pp and a PA times cosine alpha. Again, this is a very general form of calculating factor of safety against the sliding, considering you might have a sloped soil on the back of the wall, and also considering passive force, things like that. But in our case over here, the back of the slope or the back of the wall, we don't have any slope, it's flat. So essentially we don't really need this one over here. And we don't really have a passive components as well. The passive components, we're talking about probably a wall, more of looking like this. So part of the soil is actually embedded, or the toe of the retaining wall is embedded into the soil, so you have a passive force going like that. So again, for our case, we don't really have it. The Ca is the adhesion between the wall and the soil. We are not giving that information here, so we can ignore this part as well. So basically, for our case, we're talking about the sigma v, which is the weight of the wall, times the friction angle, not the friction angle of the soil, but the friction angle between the wall and the soil. We're talking about the friction along this interface over here. And over the lateral earth pressure, the PA. You can use a PA, sometimes you can use a F value. Basically, it's however much force you have calculated as the lateral earth pressure. So for our case over here, the total weight of the wall is about 3,000 pounds. It's 3,000 pounds per foot, and you can just go ahead and just grab a foot for analysis. So you can just put 3,000 over there, and the friction angle, or the interface friction angle, is tangent is 20 degrees, so we have a 20 degree over here. And then the lateral earth pressure, or the lateral force, or the equivalent force of the lateral, is essentially the value we just came up with for problem number 12. That is that resultant force. And if you can still remember, that value is about 1180 right over here. So same process at this problem. So we're going to put the 1180 over here. And then the final number for this is about 0.925. And the correct answer is A, And of course, this is not really a safe design for the factor of safety against the sliding. We want to achieve at least a 1.5. So, but for this problem, the factor of safety is 0.82. Okay, so that's it for example number 13.